Hilchos Kiddush Hachodesh Perek Asiri, the laws of sanctifying the new month, chapter 10. Yesterday we started a conversation about the length of the solar year. And I told you yesterday that chapters 9 and 10 are two opinions of how long the solar year is, how long it takes for the sun to get from point zero to go all around and again come back to point zero. So yesterday we learned the opinion that it's exactly 365 days and a quarter. 365 days and 6 hours. And that brought out a lot of results about the difference between solar and lunar years, what happens after 19 years, how to calculate each season, each quarter of the year. Today the Rambam does pretty much the same thing for the other opinion, but here, even though the other opinion is more nuanced, it's not so neat. The number is not so neat. It's not just 6 hours, but the calculations at the end become much simpler because of that. That's why it's a shorter chapter. So let's see, here we go. Halacha Aleph. Shnas hachama lemisha hu oimer shehu paches merevia. The solar year, according to the opinion that it's less than a quarter of a day, because yesterday the Rambam said, some say it's 365 and a quarter, and some say it's 365 and less than a quarter. So in the opinion that it's less than a quarter, there are a bunch of opinions. How much less than a quarter? The Rambam says we're going to pick one. Mechachmei Yisrael yesh misha oimer. Among the sages of Israel, there is one who says, and this is called the Tekufa of Rav Ada, as you see on top, he was the proponent of this opinion. He says the exact amount, the exact length of a solar revolution around the earth is Shleish Meis Chamisha V'Shishim Yom. He begins with the same number, 365 days, but here we differentiate. Instead of 6 hours, it's V'Chamesh Shois, U'Tsham Meis Shiva V'Tishim Chalakim, U'Shmeina V'Arboim Rega. 5 hours, 997 units. There's 1,080 units in an hour, so it's a tiny bit less. Right. It's less than 100 chalakim. Yeah. And now he adds another number, 48 moments. The Rambam hasn't told us about this unit of time yet. Like you divide an hour into minutes and seconds.
What is a moment?
What is a moment? You divide an hour into 1,080 units, and each unit, says the Rambam, v'harega echad mishisha v'shivim b'chelek. A moment is 1/76th of a unit. So if you think about this...
Wait 1 second. 3.5 seconds is a chelek.
Yes. Divide that into 76. It's about 1/23rd of a second.
Oh my gosh.
It's a tiny amount of time. But he went down real precise. You see it on the screen. 365 days, 5 hours, 997 units, and 48 moments.
Right.
Now, this number again looks very, very complex number.
But how did he get to that?
He calculated. The Rambam will tell us tomorrow how they got to some of their numbers.
Yeah, but this is just an opinion.
This is just one opinion. There's many opinions. In this opinion that it's less than 6 hours, there's multiple opinions.
How does it rate with modern science?
With modern science, I actually checked this up last year. I'll tell you what the problem is. The problem is that the way science...
They don't know.
No, look here. 365 days, 5 hours, 48 minutes, and 46 seconds.
So does that calculate to this guy's opinion?
365 days, 5 hours, 997 units would be about 55 minutes. So it's off by about 7 minutes in today's calculation. However, there's a trick to this number. The way modern science sees the solar system today is nothing goes around in an exact circle. They talk always in ellipses, like ovals, elliptical orbits. Yeah. And so, because of that, they're never able to really account for exactly how long a solar. It varies from year to year.
But
Depending on the orbit, the magnetic field, everything is always changing.
But even NASA
yeah.
today?
Yeah. They have super precise tools, but they admit themselves that there's something that's off with the magnetic force that pulls, the gravitational force, always pulling things in different directions. Tiny, tiny fractions. So, anyway, says the Rambam, Ulefi cheshbon zeh, according to this calculation of the solar year, Tia toisefes shnas hachama al shnas halevana, what is the addition, or what is the difference, the discrepancy between a solar and lunar year? So according to the other way, 365 and a quarter. So we have the past few chapters. It's 10 days, 21 hours, 204 units. But according to this calculation, the difference is a bit less. Asara yamim, v'achas v'esrim shah. It's also 10 days, 21 hours. But here we go off. Instead of 204 units, it's umeya ve'echad ve'esrim chelek u'shmeina v'arba'im rega. 121 units and 48 moments of the next unit. Simun lahem yika kika moyach. The sign for this is yika yud chaf aleph, 10 days, 21 hours. Kuf chaf aleph, 121. Mem ches, 48 moments. And why is this number so advantageous? Because now, if you do the math, and it's pretty tedious, but if you do the math, after 19 years, there is no differential. Not even the small one. Yesterday we learned there's an hour and 485 units if you go with this, if you go with the other version. If you go with this version, after 19 years, there is no differential. After every cycle, here you see, the discrepancy between the solar and lunar orbit after Machzor is nothing. The sun and the moon are actually smiling. They're literally together. The solar years and the lunar years, when you do the same number of regular and leap years, same thing, 7 leap years, 12 regular years, after 19 years, it exactly aligns. Halacha Beis, let's remember that the solar year is made up of 4 tkufot, 4 seasons. From here, from 0 degrees to the sun gets to 90 degrees, that's called Tekufat Nisan. Here begins Tekufat Tammuz till 180. Here begins Tekufat Tishrei till 270. And here begins Tekufat Tevet till 0. So if the solar year, the whole evolution, is 365 days and a quarter, so it's very easy. You divide it neatly in 4 quarters. It's 91 days, 7.5 hours, as we saw yesterday. But if it's a little bit less, so we have to have the exact number. Says the Rambam, Halacha Beis, bein kol tekufo lefi cheshbein zeh, between each equinox or solstice, between each quarter of the year, according to this calculation, will be echad v'tishim yoim v'sheva shois, also 91 days, 7 hours, but not 7.5 hours equal. Rather, 7 hours b'chamesh meis v'tisha asar chalakim ve'echad u'shleishim rega. 519 units, as you see over here, and 31 moments. In other words, from the point where the sun's aligned with the equator till it's at its most northerly point over here, takes 91 days, 7 hours, 519 units, 31 moments. Then it gets to the equator again, then it gets down to this most southerly point, and then it comes back over here. Each quarter takes this amount of time. Siman Lahem, Tzadik Aleph Zayin, Tavkuf Yutes Lamed Aleph. The sign for this is 91, 7, 519, 31. Say you have under your belt the information for when a specific equinox or a specific season began. Just add this number with those moments. It's very, very precise math. Just add it. You will know the following tekufa. The same way we explained when it came to the seasons of the year. When the year was 365 and a quarter, where it's much simpler, but it's the same idea. You just keep adding that amount of days. So here also, add that amount of days, hours, units, and moments, and you'll get to the next tekufa. Now here the Rambam says something fascinating. Tekufas Nisan lefi cheshbein zeh, according to this calculation, the very first tekufa, the very first time the sun entered 0 degrees on its orbit, haisa b'shana rishayna shel yitzira, was during the first year of creation, kaidem mailad Nisan, just before the conjunction that took place in the month of Nisan, b'teisha shayis v'sheish meis v'shnayim b'arba'im chalakim, just a lead of 9 hours, 642 units. Simun lahem tes tarmab. The sign for them is 9 hours, 642 units. I'm going to put quickly for a second a slide from yesterday. This is yesterday's slide. When you go with the year being 365 and a quarter days, the Rambam said the very first Tekufas Nisan was 1 week, 7 days, 9 hours, 642 before the Molad Nisan. As I explained yesterday, that's because we were calculating the creation of the world happened in Tishrei. So the Nisan Tekufa was a pre-creation Tekufa. And therefore you have to work backwards, and when you work backwards from the post-creation, you get the difference of a week, pre-creation. But according to this opinion, as the commentaries explain it, Rav Ada, besides for having a difference in the length of the solar year, he also differs on when the world was created. It's his opinion that the world was created in Nisan, not in Tishrei, such that, watch where the blue line moves, it moves here. Only the first molad of the moon is a pre-creation one, but the first tekufa of the sun is actually post-creation. Tuesday night of creation was the month of Nisan, and the sun began to function on the Tuesday night. So the only thing that we're going from pre-creation to post-creation is in terms of the molad, the conjunction. You do the math from one conjunction to the next, it's 29 and a half days, 793 parts. Do that 6 times, you'll get to Wednesday morning, 9 hours in the morning, 3:36 a.m. But the thing is that once you hit Nisan, you're already post-creation. So the difference between these two moments, Tuesday night and Wednesday morning, isn't a week apart. Now it's literally 9 hours apart. The Tuesday night of creation and the Wednesday morning of creation was when the first Tekufa and the first Mola took place after creation. Why is this important? Because this becomes the essential lead that the sun holds over the moon. The sun entered 0 degrees, and then it took another 9 hours for the moon to meet up with the sun. That is the extent of the lead that the sun carries over the moon. From then on, every 19 years, the sun and the moon return to exactly the same position. There is no differential anymore. And therefore, the lead that the sun holds over the moon is once again just 9 hours and 642 units. And it keeps on circulating. Unlike yesterday's chapter, where it got very complicated. Every 19 years, you have to account for the gap closing by an hour and 485 chalakim. Here, it's very steady. Since both the first Tekufa and the Molad of Nisan, which are relating to each other, happened post-creation, they're much closer in time, and that difference stays forever. V'chein hi la'olam, as the Rambam says, it's going to be always that way. B'chol shana rishayna min shel kol machzer. At the first year of every new cycle of 19 years, kaidem molad Nisan b'teisha shoyis v'sheish meis v'shnayim b'arbaim chalakim. The sun will enter 0 degrees. That the kufa of Nisan will take place before the conjunction of Nisan by 9 hours, 642 units, and that's it. And that's why yesterday, when we had this whole complicated slide of how to calculate the date and time of the first tekufa of a cycle, and we had to first gather all the differentials, the hour and 485 units. In today's chapter, doesn't apply. This whole calculation is out the window. Because if you're at the beginning of a cycle of 19 years, you always know. Just figure out when the molad is, the conjunction of Nisan, back up 9 hours, and you have it. You know when the tekufa is. Now, halacha dalet. Once you figure out when the exact vernal equinox is of the first year of any cycle, just keep going. 91 days, 7 hours, 519 units, 31 moments, for every equinox and solstice till the end of the cycle. And once you get to the end of the cycle, it just starts again. Now, that only works for the first tekufa in a cycle. Because then the sun and the moon, after 19 years, come right back into alignment. But during the 19 years, even according to this opinion, you always have a differential of about 10 and a half days to the sun and the moon's calculation. And so if you want to know during a given year, within a cycle, when the tekufa is, you have to do a little math. If you want to know when will be the vernal equinox, according to this calculation, in a regular year within the 19-year cycle, so yesterday, it was a much more complicated, the whole thing over here. Because again, you begin with the differentials of the hour and 485 units per 19 years. But here, we can just ignore every early cycle of 19 years because it just came back to the same position. So we have a much simpler calculation, and it goes like this. You start with figuring out how many years passed in this cycle. How many full years passed in this cycle. Take into account the differential between the solar and lunar years after that 1 year, or after those 2 years, or 5 years, or 7 years, however many years have passed from the beginning of the cycle till now. Vihi, Yud Chaf Aleph, Kuf Chaf Aleph, Mem Ches. 10 days, 21 hours, 121 units, and 48 moments. The Kabbalah call it a Goyim Chalakim. Every group of 76 moments turn into a unit. V'chala Chalakim Shois. Every group of 1,080 units turn into an hour. V'chala Shois Yamim. Every 24 hours turn into a day. The same way you do with the molad, with the moon. The tigra min hakoil, the entire accumulated number, subtract from that. Teisha shois v'sheish meis v'shnayim b'arbaim chalakim. Subtract the essential lead that the sun holds over the moon. 9 hours, 642 units. The hanishar, and whatever remains, tashli chodshe levana, divide by lunar months. Every 29 days, 12 hours, 793 parts can be subtracted from the cheshbon because those have already been accounted for in the leap years that have passed during this cycle. Because during a leap year, you add a month to compensate for that. The hanishar she'ein by Hachodesh levana, the remainder which is less than the amount of a lunar month, toisif oisei al melad nisan shal ois shana, figure out when the conjunction of Nisan will be, simply add the total that you have in your hand, to when the conjunction was. And the moment to which the number arrives will be the vernal equinox of that year, because you've taken into account all the difference between sun and the moon. You've moved away all the months that have already been compensated for, and now you have the time distance between the moed and the tekufa. Says that Rambam halachavav v'nirin li hadvarim. It seems to me, it appears to me, shal cheshbon tekufa zu hayusaimchin le'inyan ibur hashana be'ez shebeis den agadol matzoi. Of the two opinions that we discussed, yesterday's more round, approximate opinion, and today's more exact opinion, the High Court, when they calculated the calendar to make leap years and months, they would rely on this one. This is how they understood the solar year, the more exact solar year. When they used to make leap years based on the time or based on the needs. Why did they use this one? Because this calculation is truer than the first one. The Rebbe once said, the Rambam just says emes yoser, it's more true. The first one is also true. And that's why we use it for certain areas in halacha. Like we said yesterday, 28 years making birkat hachama, blessing on the sun, is only true according to yesterday's opinion. But this one is more true, more precise as it relates to making the calendar. It's closer to those things that are explained in geometrical and astronomical books, more than the first calculation. Where we said that the solar year was 365 days and exactly a quarter of a day. So this is the one that the court used to use, even though it's more complex, even though it's more nuanced, but it's more precise.
It seems like it's easier.
Huh?
It's more precise and easier.
It's more precise in the results. It's more complicated in getting through the process, because now you have to take into account moments, 76th of a unit. It's very, very complicated. Yeah. But the results that are going to be yielded are much, much clearer. Now the Rambam gives a very important caveat, and it's going to be explored multiple times over the coming chapters. The calculations of both equinoxes, whether we go with this chapter or we go with the last chapter that we've explained, you should know, hakoil bekeruvu. It's all approximate, uvemahalach hashemesh ha'imtzai loy bimkoima ha'amiti, and is only true in the sun's average orbit, not in its true orbit. Aval bimkoima hashemesh ha'amiti, the true placement of the sun, tiyet kufas nisan bizmanim elu. Nowadays, the vernal equinox will always be about 2 days before the vernal equinox that would come out based on these calculations. It's about 2 days before on the true path. Whether you go with a complete quarter of a day or less. Now, what does that mean, just quickly? Because we're going to explore this later at length. I've told you before a number of times that all the calculations of the sun's orbit are when you think about the center, the sun's orbit relative to its center. But it's off-center to the earth. So you see that you will observe, if you're standing here, you will observe a different point in the stars than if you're standing over here. So watch what happens. This is going to be, right over here is 0 degrees on the ecliptic, on the major line of constellations, how we measure where the planets are. From a viewpoint of someone standing on Earth, when does the sun reach this point? You can see it's just before 0 degrees on its own orbit. So the vernal equinox that we've been talking about is when the sun gets on its own orbit to 0 degrees. But by this time, when it's already just behind 0 degrees, we're already seeing it from here, from Earth. We're already seeing it at 0 degrees.
Where are you on Earth here?
In Jerusalem, Yerushalayim. That's why the Rambam says, whatever calculations you're going to come up with, the real tekufa, real means real to you, to the observer on Earth, is going to be 2 days earlier.
Actually,
and he says,
if you look at this, Yerushalayim Merkaz Haolam.
Yeah. And he says that it's only nowadays, in these times, and we're going to see why in chapter 12, because we're going to see, it gets very complicated. The point of the off-center keeps moving. In other words, the entirety of the sun's orbit is moving. So in the Rambam's times, this is where the apogee was. The highest point away from Earth was over here. So therefore, looking at 0, you would get here about 2 days before the sun got to 0. But nowadays, this point has actually moved. It's a bit further, it's about over here. So the real tekufa could actually be even more than 2 days before, about 3 days before. But the principle is the same. When it comes to the calendar calculations, we're looking from our perspective. We don't care about the center of the sun's orbit. We care about our observation point. And in our observation point, we must always measure the planets against how we see them in the stars. And that'll always cause adjustments, which are going to cause a lot of complications. As we study the next couple of chapters, we're always going to be adjusting from the center of the sun or moon's orbit to the center of our observation point, which is the earth, as we're going to see, God willing, in the coming chapters.